For a given geometric sequence, the third term, a sub 3, is equal to 11/16, and the eighth term, a sub 8, is equal to 22. Find the value of the 12th term, a sub 12. If applicable, write your answer as a fraction. The first thing you want to do is write the formula for a geometric sequence. That is, a sub n is equal to the first term times the base, or the common ratio, r, raised to the n minus 1 power. We don't have the common ratio. We don't even have the first term. We do have a sub 3. A sub 3 is the third term, which is equal to 11/16. A sub 8 is equal to 22. So why don't we use these input and output values to figure things out? So I'm going to highlight this. This is 11/16. And that occurs when n is equal to 3. So we're going to put 11/16 here, which is the output. And we have what? We have a sub 1 times r. And then we know what n is. N is 3 minus 1. I mean, n is 3. So 3 minus 1 is 2. So we get this equation called 11/16 is equal to a times r squared. We're going to use the other equation as well. Let's use the fact that a sub 8 yields 22. So our output value is 22. Our output value is 22. And when does this occur? This occurs when a sub 1, which we don't know, is multiplied to r, which we don't know. But we do know that n in this specific case is 8. So what's 8 minus 1? I'm sure you guys can do that. That's 7. So we get this new equation here. We get 22 is now equal to a sub 1 times r to the 7th power. It would be nice to be able to find the common ratio. There's a couple things we know. We know that a sub 1 is not 0. We also know that r, the common ratio, is not 0. If either one of these are zeros, we won't be talking about a geometric sequence. So we know that by definition, a sub 1 is not 0. The common ratio is not 0. Let's take this first equation over here, and I'm going to solve for a sub 1. So that is going to be 11/16 times r squared. I'm going to take this and substitute it over here. And let's see what we get. 22 is now equal to a sub 1, which is 11/16 times r squared. And r to the 7th power. Now we have r to the 5th power. We got 22 times 16 divided by 11, which is equal to r to the 5th power. That's 2 times 16, which is 32, which is equal to r to the 5th power. I'm going to take the 5th root of both sides, not a problem. 5th root is a 1-to-1 function, so we get r is equal to 2. So we get the common ratio to be 2. Now we need a sub 1. I'm going to go back to, let's say, this equation here. Let's use that equation to get a sub 1. So going back to the triple star equation, I'm going to solve for a sub 1, which is 11/16 times 4, which is 64. And there is a sub 1. Awesome. We need to find the value of the 12th term. Well, we're not quite there yet. I'm going to write the new sequence, geometric sequence, a sub n is now equal to 11/64 times r. R is 2 raised to the n minus 1. And that is really, really key. Even though this is not the final answer, we need this in order to find the 12th term. Remember, a sequence is a function. So our output value is what? The expression that we're looking for is a sub 12. Let's find a sub 12, which is just 11/64 times base 2 raised to the 11th power. And of course, you could put that into your calculator and figure that out. 22528 over 64. This is reducible by 4, so let's write the expression again. 5632 over 16. This is once again reducible by 4. So let's reduce it again. Now you're probably wondering, how come I know it's reducible by 4? If the last two digits is divisible by 4, then the entire number is divisible by 4. Just like this is divisible by 4 again. So this is going to be a really nice number. This is now 352. 352. So the 12th term, therefore, a sub 12 is equal to 352. There's your final expression. I'm going to circle, well, you could just circle the whole entire page. There's a lot of work involved here. I am going to circle the final answer, but make sure you can show your work.